This video, we're going to learn how to do Lewis structures for simple covalent compounds. So in any Lewis structure, we have a series of organized steps. The first two steps can be interchanged. You can do either one first. It doesn't really matter. In this video, I'm going to do the calculation of the number of valence electrons first. So here we have two compounds. We have CnH2 minus. There is a minus sign here, so don't forget the minus sign. And then NOH2 plus. Likewise, don't forget the plus sign. We need to determine the number of valence electrons total in this structure. So let's start with the left one, and then we'll also do the right one. How can we determine the number of valence electrons? Well, of course, going to our periodic table, we know that group 1 elements have 1 valence electron. Group 2 elements have 2 valence electron. 13 have 3, 14 have 4, 5, 6, 7, and helium be better over here because it only has 2 valence electrons. It only has 2 electrons. Everything else has 8 valence electrons. And so we look at our first structure. We can actually note all of the atoms. So we have carbon, nitrogen, hydrogen, and oxygen between these two structures. And we can find here that carbon has 4 valence electrons, nitrogen has 5, oxygen has 6, and of course hydrogen has 1. These are good ones to memorize, but even if you don't memorize them, you can always refer to the periodic table and figure out how many they have. So let's just write it down. So hydrogen, each hydrogen has 1 valence electron each. Each nitrogen has 5 valence electrons, and each carbon has 4 valence electrons. Here, each hydrogen has 1, each oxygen has 6, and each nitrogen has 5. Down at the bottom, I multiply by the subscripts. So I have 2 hydrogens, so here, total 2 electrons. There's only 1 nitrogen, so all nitrogens account for 5. And carbon's 4. Likewise here, same thing, 2 hydrogens, 1 oxygen, and then 1 nitrogen. Now, what about these charges? So recall that each negative charge corresponds to an extra valence electron. So if I have a 1 minus charge, I have to add on 1 extra electron. If I have 2 minus charge, I have to add on 2. So here I'm going to add on 1. And so this is going to be 1 extra valence electron. What about a plus charge? A plus charge means that this compound is deficient 1 electron. Deficient. Deficient just means it's short 1 electron. And so here for the positive charge, I actually have put a negative 1 down. Counting the total number of electrons, so I have 4 plus 5 plus 2 plus 1 gives me a total of 12 electrons. And here 5 plus 6 plus 2 equals 13 minus 1 also gives me 12 electrons. So both of these structures have 12 valence electrons total. So I can go in here and I can write down. So I have 12 here, and I have 12 here. Central atom is always going to be the least electronegative atom, except for hydrogen. Because remember, hydrogen can only hold 2 electrons, and so it can never be a central atom because it can only form 1 bond. Right? Thinking of simplest case, let's just think H2. So here's a hydrogen bound to a hydrogen. Here, 2 electrons per bond. Each hydrogen already has 2 electrons, can't form any more bonds. And so hydrogen will never be the central atom. So we need to figure out what's the least electronegative atom other than hydrogen. So here I have CnH2 and I have NOH2. So we're going to be comparing carbon, nitrogen, and oxygen. Recall that electronegativity increases going to the right up to group 17 and then going toward the top. So long story short, the least electronegative atom is going to be the one furthest toward the bottom left. In this case, all of my elements except for hydrogen are in the second period. And so I'm just really comparing oxygen, nitrogen, carbon. Among these, nitrogen and carbon are going to be the least electronegative. So for the left structure, carbon is going to be the central atom. And for the right structure, nitrogen is going to be the central atom. And so now we finish steps 1 and 2, determining the number of electrons in our structure, valence electrons in our structure. And now we're going to draw a preliminary structure, which includes the central atom with single bonds to all peripheral atoms. So here is a carbon as a central atom. Here's a nitrogen as a central atom. And now I'm going to draw on this left structure bonds to 2 hydrogens and a nitrogen. And here, bonds to 2 hydrogens and an oxygen. Now I count the total number of electrons in bonds. Recall that each single bond has 2 electrons. So for this structure, I have 2, 4, 6 electrons in bonds, and likewise here, 2, 4, 6 electrons in bonds. So I'm going to write that there are 6 electrons in bonds. Call these 6 bonding electrons. And since in both structures we started out with 12, 12 minus 6 means that we have 6 electrons remaining that we have to allot to other atoms. And so now we can start with our 2 preliminary structures. Oops. And allot the remaining 6 electrons to the peripheral atoms. For these 2 examples, we're fortunate because hydrogens can't accommodate any more electrons. They already have 1, 2 in each bond. Oops. They have 2 here and 2 here, right? 2 here and 2 here. And since hydrogen can only form single bonds, the only place for electrons to go are on either the nitrogen and carbon here or the oxygen and nitrogen here. We start by giving the electrons to the more electronegative atom, which of course are going to be our peripheral, because our most electronegative one is our central. And so we're going to give electrons to nitrogen until it has 8. Well, it has 2 electrons in bonds already. So I'm going to give it 1, 2, 3, 4, 5, 6 electrons. And now all 6 electrons have been exhausted. I have no more electrons to give to carbon. Likewise here, I'm going to give 1, 2, 3, 4, 5, 6 electrons to oxygen. And I have no more electrons to give to oxygen, or to give to nitrogen. Let's do some electron counts. So here, nitrogen has 2 electrons in bonds, 6 non-bonding electrons. It's 2, 4, 6. So nitrogen has 8 electrons. Carbon, on the other hand, only has 2, 4, 6 bonding electrons. Likewise here, oxygen has 8 electrons, and nitrogen has 6 bonding electrons. We know that all elements, except for hydrogen, want to have 8 electrons, and that is called the octet rule. So, octet rule, that all atoms, except for hydrogen, want 8, and elements in the second period can only have 8, maximum. Elements in third periods and below can have what are called expanded octets, and we'll get there later. Well, here, nitrogen has 8, carbon has 6. How can I give 2 electrons to carbon without necessarily taking any from nitrogen? I can just draw a double bond here. Likewise here, in the right structure, I can draw a double bond here. And now putting it all together, I'll have my central atom. I now have a double bond between nitrogen and carbon. Could draw my hydrogens here. And now recall, one of the lone pairs here went toward making the double bond. And so now 2 lone pairs remain on nitrogen. And we can do our electron tally. So there are 2 4 electrons in the double bond, and then 2 4 electrons in the lone pairs for nitrogen. So nitrogen has 8 electrons total, 4 bonding and 8 non-bonding. And carbon has 2, 4, and then 4 electrons in double bond. It also has 8 electrons. However, for carbon, all 8 electrons are bonding electrons. And so this is the best structure for CnH2 with the minus charge. What about NOH2? Once again, I'm just going to draw my scaffold structure that I started with and then do 2 bonds to oxygen. I'll draw 2 of my remaining lone pairs here on oxygen and do my tally. So 2, 4 non-bonding electrons on oxygen, then 4 bonding electrons. And so that's a total of 8. And then here for nitrogen, I have 4 in the double bond and then 6, 8 total. For nitrogen, all bonding electrons. And these are the most stable Lewis structures for these 2 compounds. Notice that they're very similar. Just to summarize, if you do all of the Lewis structures as following these steps, you can't go wrong. Step number 1, count the number of valence electrons. For both of these compounds, we determined that there are 12. Determine the central atom, which is going to be the least electronegative atom, except for hydrogen, which can only accommodate 1 bond, and so it will never be the central atom. For the left compound, the central atom is C. For the right compound, the central atom is N. Third step, draw a preliminary structure in which we have single bonds between the central atom and all peripheral atoms. And I'm going to bring both of these down a little bit just so when I upload these, it looks nicer. And we count the number of electrons in bonds. So we started off with 12 electrons each. There are 2, 4, 6 electrons in these 3 single bonds. And so we have 12 minus 6, 6 electrons remaining. We allot these remaining electrons to the peripheral atoms, starting with the most electronegative one. Fortunately, there's only 1 peripheral atom for us to allot electrons to, so it makes our job easy. So it's 2, 4, 6 electrons go to nitrogen. Now we have no more electrons left to allocate. Likewise, 2, 4, 6 electrons to oxygen. We count our electrons here for each atom. 6 are on carbon for the 3 single bonds, 8 are on nitrogen, 6 non-bonding electrons, and 1 bonding pair. Likewise, 6 non-bonding electrons on oxygen, 1 bonding pair. We need to give the central atoms 8 electrons without necessarily taking away electrons from the peripheral ones. And so we draw a double bond using a lone pair here and a lone pair here. And then we get our final structure, do our electron tallies. And here we go.